Hello and welcome to this C programming video. My name is David Thorne. In this video I'm going to talk to you all about the string literals and the possible undefined behaviour that you may get when trying to manipulate the value in memory. So rather than explanation, let's just do demonstration. So let's create a simple string literal here by using a char pointer name. The name variable is equal to David. If we want to change the name of the, well, let's just print out the value first of all, just to show you what the value is, and then just say name, just to show you that we're all, whoops, printf, just to show you that we're all working happy days. Yes, we are. All right, let's now print it out again, and we'll change the name to Thorn, and we see Thorn, and we'll change the name to Getty, just to show you we can change the length of it as well. All right, and this is a really long string. Okay, so we can show you that whatever we place in it, it will extend the size of it. So in the background, all of the null terminator is going to be added, this, that, and the other. So this is all happening within inside of the compiler. Okay, however, if we then want to actually change that one string, we can't do that, right? What we can do is we can change the complete value at that one location, but we can't individually change the value to that one pointer because this is a pointer, right? If we then just said that the first char is then going to be 7 and we run this, you'll see it compiles perfectly fine, but it crashes. And this is where the undefined behavior is, because this name, the data, the string literal stored at that one address is read-only. Okay, however, we can change the memory, or we can change the string value located at that address, but you cannot actually manipulate that memory directly. Okay, but that doesn't mean to say that all string literals have this property as well. So let's just create another char pointer and say surname, and this time we'll create a malloc, and we know that my surname is 5 letters, so Thorn, plus in the null terminator we need 6. Now in order for us to update this memory, right, we could use the memset, but that comes part of the string.h, and I want to try and do this without any other additional header files, just to show you purely how it's done manually. So in order to be able to initialize this one surname, we need to add that null terminator. So first of all, and if we just now put the value of a surname, let's just say surname here, and we run this, you'll see that we get nothing after it because it doesn't have a null terminator. So we'll say surname with the index of 5 is obviously then 6th position, and we'll just copy and paste this 4, 3, 2, 1 here. So we now come to 0, 1, 2, 3, and we need it one more time to go to 4. And here we obviously put then we want surname Thorn, and now when we run this, you'll see that we get surname Thorn. So this one we can change all we like, but we have to make sure that we obviously free this up as well because we managed the code. All right. So if we now want to come and change a place in the memory, right, or we change the value at the memory, we just say pointer. So we dereference the surname to say this, and then we just say another surname totally. And when we run this, you'll see that we get the problem once again, right? Because all we're doing is we're updating the character itself. And remember, a char pointer is just a character, so we need to actually update all of the places inside of the memory, and that's why you get in this \205 and so on, because we're not changing that first position. So you've got to come here and then say the 0 is going to be equal to the character of A once again, and we don't want to dereference it. So So we've already seen that we can't say star name is equal to W and then run it, because we get undefined behavior. All right. However, when we come here and say name plus 0 is equal to W, let's see what happens now. Okay, so we still get problems there. All right. But let's see whether we can do this to surname. Let's run surname. And there you can see that it works perfectly fine with surname. Let's just to show you that it's actually going to update the W here. So creating your own memory, right, and then having memory that is purely read-only, you can see that we can't change it anyway, all right? But they're both string literals. They're both part of this scope here, but it's how we created it. And by creating this pointer with malloc, we are saying to the C program, the runtime, hey, we manage this. And, what we want to put in this memory is what we want. But this is saying, hey, you manage this, and it's purely read only. And as I've shown you, you can change the value, the string within inside of that address location, but you can't change the value at that location, all right, because it's read only. It's in the read only section. I hope I've described this well enough for you. These are obviously string literals, and what they're not are character arrays. Okay, so let's just say brand is equal to my new brand here. All right, these are not the same things. This is a char array, and this is then a string literal. All right, and if we just place the value of here instead, and you can see my new brand. So don't be misled by this, all right, because they're two separate different things. And if we say brand and 1 is equal to 5, for example, and we run this once again, you can see M5 new brand, right? And this if you're creating a new BMW or something, right? So they're two completely separate things. So please don't mix the two up. All right, how they are stored in memory is that they are still part of the memory here, or in part of the application, but the data stored at that one location is not read-only. However, a string literal like this is read-only. Okay, but we don't have to free up this brand at the bottom. And if we do, just for the sake of having fun, just to show you what another problem will be, or undefined behavior will be, you can see this attempt to, let's just stop it once again just to show you the attempt to call free on non-heap object brand. Okay, this is the key thing here, is non-heap, right? Non-heap means it's on the stack. The opposite of heap is then stack, and all of this is on the stack apart from surname, which is on the heap. And so we can't start managing managed memory that's been managed by the system. Surname is unmanaged, means that we are managing it, and these string literals are managed memory by the application or whatever runtime is running the application, and so on. So with that said, I hope I've covered it enough for you to understand what string literals are, when they got read-only memory, and how you can manipulate string literals using pointer arithmetic. And anyway, with that said, I hope that you got something out of this one video. I hope you've learned something from this one video. If you did, don't forget to like, subscribe, share. If you've got any questions, feedback, or concerns, or any enhancements, then let's start a conversation in the comment section down below. I'm no C expert, all right? I make these videos, one, to improve my teaching ability, and also help me to enhance my understanding of low-level programming. My expertise is in Swift and a few other areas, but I find that today's society, with how technology is going, we've got more and more microcontrollers, embedded systems, IoT. It's becoming bigger and bigger and bigger. That it's really important that software developers that want to move very close to the hardware level to work on these types of systems, it's really important that you can understand and read the code. Whether or not you're writing the code, there's lots of ChatGPT today that can write the code for you, but you've really got to be able to debug it and also, yeah, that's it. That's just basically the only thing. If you want to write the code yourself, then obviously you're going to spend a lot more hours in learning C and how using other frameworks. With that said, thank you very much for watching. My name's David Thorne, and I'll see you in the next video. Ciao, ciao, and goodbye.